Hello, everyone. Welcome to today's class on Azure Modules. Today, we'll dive into the transformative world of modules, the cornerstone of writing reusable, maintainable infrastructure as a code. If you've ever found yourself copying and pasting the same resource definitions across multiple Bicep files, modules are about to revolutionize your workflows. Get ready to simplify your workflows and enforce consistency across Azure environments using Azure Bicep Modules. See you soon. So, what exactly are bicep modules? At its core, a bicep module is simply another bicep file, but designed for a reuse. Think of it as like a function in traditional programming. So Bicep module kind of accepts specific parameters as inputs. It orchestrates the deployment of one or more resources. It can return outputs for other parts of your infrastructure to consume. It helps us to, of course, avoid duplication by eliminating redundant code, making our infrastructure definitions dry, simply meaning do not repeat yourself. In terms of enforcing consistency, it ensures all deployments of a specific resource type adhere to predefined standards and configurations. So, helping us to maintain a standard across all deployments. So, as well, it helps simplify deployments, break down large bulky infrastructures into smaller, manageable, and easier to understand components. Now it's time to draft our first module using the storage account example, which we've done before in previous session. So we'll take this as a module and try to, do some changes and deploy this resource as a module. So first of all, let's quickly highlight that we have parameters for values that might change with each deployment, such as the storage account name and the location we are seeing here. We also have included sensible default values for conveniences. All right. The output statement is crucial as it also allows us to expose important information like resource ID and name. This is particularly useful when other resources need to reference this storage account. All right, this all falls back to things we have treated before, which are how the parameter, how the variables or the output are all coming together to create a simple module. Now that we have a storage account module, it's time to integrate it into a main bicep file. This is where the magic of true reusability comes alive. We will use the module keyword to call our newly created storage account module. This action effectively embeds and deploys the resources defined within our storage account.bicep file. All right. So we assign a symbolic name, all right, storage account mode to our module instance, specify its paths, and pass these in necessary parameters. Notice how we can easily reference the module output such as storage account mode dot output dot storage account id. This capability is fundamental for kind of chaining resources dependency and building complex interconnected infrastructure. Here we have our module uh, that we showed before, the storage account module, just a simple module. And here will be the calling template, which will call the module, all right, from what we saw previously. So it's the same example here, just a copy and paste of that same example. Then when we deploy this, we'll see that this actually gets deployed once we run this deployment command here, and we can see the outputs of the deployment has gone through. So basically, this as a module, this template file as a module will allow us to recreate from that module without having to actually copy all these codes here into our main .bicep file. So that's really what's happening under the hood to maximize the benefits of Bicep modules and ensure our infrastructure as a code is robust, scalable, and adhered to simple best practices. We will follow these guidelines. The first one we'll look at is single responsibility. In each case, each module should focus on deploying one logical component, such as a storage account or a virtual network. Um, Another thing we could look at is parameters and outputs. We need to avoid hard coding values. They are likely to change. Instead, we rely on flexible parameters and clear outputs. The third one here will be versioning our modules. We could store modules in virtual controls like Git or registry using tags for version management. Another one to consider is keeping them very small. Conciseness is key. A module exceeding 500 lines might indicate it's attempting to do too much. All right. Um, Another one here will be don't over modularize. If a resource is used only once, creating a separate module might introduce unnecessary complexity. So let's watch out for all of this and take this as a guideline when creating modules. Looking beyond local files, Bicep modules can offer incredible flexibility as we can extend beyond local files paths to enable true organizational widespread reusability. You can reference modules from a variety of sources like Azure Container Registry, ideal for centralizing and sharing modules within teams and across large organizations, ensuring consistent deployment. We also have the public Bicep Registry, now home to Azure Verified Modules, AVM, Microsoft official, well architected, compliant modules. We also have the likes of GitHub, GitLab, Azure repos, which are mainly um, version control Git registries, Git repositories, and we can also help to reference modules directly from these Git repositories via their direct URL links, facilitating collaborative efforts between different teams. Let's have a quick recap to what we've discussed today on Bicep module. We talked about modules being reusable in that they are distinct Bicep files designed for component reused. We also look into the flexibility with parameters and outputs. We use parameters for customization and outputs for inter-module communications. This is how Bicep module has really played a key game in reusability. Now, we also talked about the column module, which helps to integrate modules into our main Bicep files using the keyword module. We also talked about design principles, how we can follow single responsibility versioning and keeping modules concise. All right. Um, Thank you for joining us in this session. Next time we will explore using modules in ACR, AVM, GitHubs, GitLab links. I hope this session has equipped you with the knowledge to write more frequent, reusable IAC code using Bicep. Don't forget to like and subscribe. See you next.